Okay, once again, good morning everyone. Okay, so we are going to discuss this morning about the types of energy. So there are topics that are going to be discussed this morning. So this is focused on the types of energy. Okay, so I'm going to present first the objectives for this study. Okay, so there are three objectives. Okay. One, internalize the importance of the types of energy. Number two, articulate the types of poisonous gases and evaluate the nature of fire in arson investigation. Okay, so these are the objectives of the topics that we're going to discuss this morning. Okay, let us start with the types of energy. So there are common sources of heat. The types of energy. So what are those types of energy? So there are four. So actually there are four types of energy. The chemical, number one is chemical energy. Number two is electrical energy. Number three is nuclear energy. Number four is mechanical energy. Okay. So these are the types of energy or the common sources of heat. One of these is the chemical energy. So what is this chemical energy? Okay. So the chemical energy, it is the most common source of heat. So this is the most common source of heat in combustion reaction. So the chemical energy, which is the most common source of energy in combustion reaction. So when any combustible is in contact with oxygen, oxidation occurs. So when combustible materials which are in contact with the oxygen, then oxidation occurs or will happen. The reaction of this process results in the production of heat. So when this combustible is in contact with the oxygen, then oxidation occurs. That this reaction of the reaction of this process, so the process of the reaction of the process of oxidation, that results in the production of heat. So that produces heat. Examples is heat generated from a burning match. So the heat which is generated from a burning match, or the self-heating or spontaneous heating. So that is chemical energy. So when this combustible which is in contact with the oxygen, then that oxidation will occur. And this process that results in the production of the heat. Okay, so that is for the chemical energy. Another energy is the electrical energy. So what is this electrical energy? Why does electrical energy differ from chemical energy? So the electrical energy is that can generate temperature. So this electrical energy generate or produce temperature high enough to ignite any combustible materials near the heated area. So what does it mean? That this electrical energy, this energy is coming from electricity. So the electrical energy can generate temperature high enough to ignite any combustible materials near the heated area. So what are those factors that involve in electrical heating? So it is said that electrical energy, the energy that generate or produce temperature high enough in order to ignite any combustible material near the heated area. And what are those factors which are involved in electrical heating? So one of these is current flow through a resistance. Number two is overcurrent or overload. Then three is arcing. Four, sparkling. Five, static. And the six is lightning. So one of the factors involved in electrical heating is current flow through a resistance. So this is coming from an electrical circuit. So current flow through a resistance. Okay? So when electricity is connected in your respective houses, that energy is coming from the Noriko. So the current flow through a resistance. So that produces energy. So if you are going to use iron, when this is connected to the electrical outlet, what will happen? So it produces heat because of because the heat is coming from the so-called electrical energy. Another is overcurrent or overload. So what does it mean? It means that the load of the electricity is in excess of the required load. We call this overcurrent or overload. So there are times wherein the current or the electricity is overload or underload. So if it is overload or overcurrent, so it means that generate the temperature high enough in order to ignite these combustible materials. That is why when portion of a wire is damaged, that will initiate the fire because of the energy coming from the electricity. So the overcurrent or overload. Next is arcing. So what is arcing? So if you are going to use welding machine, you know, the welding machine is going to be connected in the electrical outlet. So when the welding machine is in action, or which is going to be used with the so-called rod, or in the study of welding, that is not called rod but electrodes. Okay, so welding electrodes. So when this is melted, it is arcing, because that the welding rod is going to be what we call this, contacted with the other metal. So when this is contacted with the other metal, it is arcing. Another is sparkling. So aside from arcing, the welding machine also, the result of the product of melting the metal, because in the welding, you are going to melt two metals. You are going to connect one metal from the other metal. So sparkling. So that sparkling, okay, sparkling, it means that when there are papers near to the area where the person is having or is doing a welding work, the possibility there, because of sparks, the papers which are near to that area where the person is doing welding work, there is a possibility that because of the heat, because of the high temperature, that will cause fire. And another is the static. So it means that the what we call this, the energy is what we call steady. So steady, the energy is steady. Then another is lightning. So this lightning, actually this is caused by nature. So when lightning hits to a particular object, it produces a large volume of what we call this voltage. So lightning. So this lightning, even though this is produced by nature, this is also bring high energy, electrical current or energy from the nature. So these are the factors involving electrical heating. Next is the nuclear energy. So what is this nuclear energy? Okay, so nuclear heat energy is generated when atoms either split or combine. So when these atoms, when these atoms either that split or combined, so it is nuclear. So nuclear heat energy is generated when atoms either split apart or combine. Talking about split means fission, combine means fusion. So the examples given: fission heat water to drive steam turbines and produce electricity. So the fission. So this fission means splitting apart. So fission heats water to drive steam turbines and produce electricity. And this is very true in Mindanao. Maria Cristina Falls is used in the source of their electricity. And that is fission. fission heats water to drive steam turbines and produce electricity. Another is the solar energy. So what is this? So the solar energy is a product of fusion. So fusion means a combination. So this is a solar energy. This is coming from the sun. So the solar energy is a product of a fusion reaction, which is a form of nuclear energy. So this solar energy, this is a combination. So fusion means combination. The solar energy is coming from the sun. So the solar energy is a product of fusion reaction. This also produces electricity. And this solar this is coming from the sun. This is combined. This is called fusion. So the low solar energy is a product of a fusion reaction. Okay, that's nuclear energy. Next is the mechanical energy. So the last types of energy is mechanical energy. So what is this mechanical energy? Why this mechanical energy differ from chemical, electrical, and nuclear? So a mechanical energy is an energy created by friction. So this energy that's created by friction and compression. So this mechanical energy this is created in two ways, by friction and compression. So what is this heat of friction? So the heat of friction is the movement of two surfaces against each other. So there are two surfaces. The movement of the two surfaces against each other, and these movements produces sparks being generated. And it is very true when you are using stones, striking the two objects from one another, that produce sparks. And that is called the heat of friction. It is the movement of two surfaces against each other. So this movement produces sparks being generated. Okay, so this is heat of friction. So the movement of the two surfaces. So the two surfaces are moving against each other, and that the result of their movement that produce sparks being generated. Next is the heat of compression. So what is this heat of compression? Why do we call this heat compression? So the heat of compression is the heat is generated when a gas is compressed in a container or a cylinder. So the heat is generated when the gas is compressed. And this is very true in LPG. So the heat of compression, heat is generated when a gas is compressed in a container or a cylinder. And this is very true in an LPG or liquefied petroleum gas. Okay? So mechanical energy, the energy created by two ways, friction and compression. So the heat of friction, which is the movement of the two surfaces against each other, and this movement produce sparks being generated. And the heat of compression, the heat is generated when the gas is compressed in a container or a cylinder. Next is the categories of product of combustion. So there are categories of the product of combustion. So what are those categories of product of combustion? One is fire gases. Number two is flame. Number three is heat. And number four is smoke. So these are the categories of product of combustion. One of these is the fire gases. So what is this fire gases all about? So the fire gases are those that remain when other products of combustion cool to normal temperature. So the fire gases, these are those that remain when other products, so when the other products of combustion cool to normal temperature. Then common combustible contain carbon, which form carbon dioxide. So the common combustibles, such as the carbon, that forms or which form carbon dioxide and carbon monoxide when burned. So other fire gases includes hydrogen sulfide, sulfur dioxide, ammonia, then hydrogen cyanide, nitrous and nitric oxide, phosgene, and hydrogen chloride. So these are the combustible other fire gases. So the fire gases that remain when other products of combustion cool to its normal temperature. So these common combustibles such as the carbon, then that forms carbon dioxide. So this carbon which form carbon dioxide and carbon monoxide when it is burned. So when this combustible materials is burned, so the carbon, so these combustible materials that contain carbon, when it is burned, it forms carbon dioxide and carbon monoxide. Okay? So, and the other gases that also include hydrogen sulfide, sulfur dioxide, ammonia, hydrogen cyanide, nitrous and nitric oxide, phosgene, and hydrogen chloride. So there are types of poisonous gases. So what are those types? Okay? So, hydrogen sulfide, hydrogen cyanide, then hydrogen chloride. So one of these is hydrogen sulfide. So the hydrogen sulfide, a fire gas formed during fire. So the fire gas that forms during fires involving organic material that contains sulfur, such as rubber, hair, wood, meat, and hide. So this hydrogen sulfide, that the fire gas which formed during the actual fire, that involves these organic materials. And what are those organic materials that contain sulfur? That contains sulfur such as rubber, hair, wood, meat, and hide. It is colorless. So this hydrogen sulfide is a colorless, highly toxic gas with the strong odor of rotten egg. So toxic gas. This is a toxic gas that can cause poison. So this colorless, highly toxic gas with a strong odor. So the odor of this is very strong, like rotten eggs. So exposure for even a short time is dangerous. So when a firefighter is exposed to this, is very dangerous. So exposure for even a short time is dangerous, and it will ignite at 500 degrees Fahrenheit or 260 degrees centigrade. So that is for the hydrogen sulfide, and it is very this is exposure to this is dangerous. Even for a short time is dangerous. Another is hydrogen cyanide. So this hydrogen cyanide is a toxic fire gas found in oxygen-starved fires involving nitrogen-containing materials such as wool, silk, urethane, polyamides, and acrylic. So this fire gas, this hydrogen cyanide, it is a toxic fire. A toxic fire gas which are found in oxygen-starved fires that involve nitrogen-containing materials such as wool, cells, urethane, polyamides, and acrylics. And this gas is also used as a fumigant that can pose serious dangers to firefighters working in recently fumigated building. So this also causes serious dangers to the firefighters when fighting a fire. If the fire involves one of the materials which is on fire is hydrogen cyanide, and these firefighters will encounter with this in the fire scene that can cause serious danger to the firefighters working in fumigating buildings, recently fumigating buildings. Hydrogen cyanide smells like bitter almonds that may not be easily detected. So this hydrogen cyanide that smells like bitter almond, but this may not be easily detected. It cannot easily be detected. So that is why it is it poses serious danger to the firefighters. That is why firefighters which are fighting the fire, they are equipped with sophisticated material in order for them to fight the fire, in order for them not to be poisoned caused by the smoke of the fire. Then hydrogen chloride is a gas which can be fatal after only a few breaths is produced in fires involving chloride containing plastic. So this hydrogen chloride, so this is a gas which can be fatal. So this can be fatal after only few breaths of. So when firefighters, which is not equipped with sophisticated materials in fighting the fire, then it can be fatal. So only a few breaths is produced in fires involving chloride containing plastic. So it is very true. When you are going to burn plastics, it is that will cause serious dangers to one's health. So that's why a gas which can be fatal after only a few breaths is produced in fires involving chloride containing plastics. Plastic can be found anywhere, from furnishings to electrical insulation, conduit, and piping. So this causes danger to the firefighter. So that's why firefighters are equipped with sophisticated instrument or equipment for them not to be poisoned with regards to fighting of the fire. So types of poisonous gases: hydrogen sulfide, hydrogen cyanide, then hydrogen chloride. Next is the flame. So after the fire gases, let us move to the flame. So what is a flame? So a flame is the luminous body of a burning gas which gets hotter and less luminous when mixed with more oxygen. So the flame. So this flame, luminous body of a burning gas. If there is a fire, it starts with the flame. The flame is luminous body of a burning gas which gets hotter. Gets hotter and less luminous when mixed with more oxygen. So at the very start of the fire, the flame is luminous. When the fire is in progress, the possibility that the fire gets hotter and it becomes less luminous when mixed with more oxygen. Flame fades when carbon burns completely. So flame is considered a product of incomplete combustion. Why is it that flame is considered as a product of incomplete combustion? You know that flame, when the fire is started, it starts with a flame. So the beginning of the fire, it starts with a flame. And this is a product of incomplete combustion. Because that's the very start of the fire. So the flame is luminous when the fire is started. When the fire is in progress, the luminous body of the flame becomes non-luminous. And it is very hot. So it gets hotter. So this is the manifestation of fire when the fire is in its gas phase combustion. There are types of flame. Actually, these are categorized into according to the color and completeness of combustion. Then, according to burning fuel and air mixture, and based on smoothness. Okay? So, one of this, according to the color and completeness of combustion. So, according to color, this can be classified into two. What are they? These are luminous flame and non-luminous flame. So what is this luminous flame? Why is this flame considered as luminous? So a luminous flame, a reddish orange in color. It deposits salt because it is a product of incomplete combustion. It has a lower temperature. So this is luminous flame. As I mentioned, when the fire started, it produced what we call this luminous flame. And this luminous flame is reddish orange in color. Okay, so reddish orange in color. it deposits soot. So this soot, therefore the carbons, huh? Black carbons, huh? Because it is a product of incomplete combustion, and it has a lower temperature. So lower in the sense that because it is the start of the fire, it is not very hot. That is why the color of the flame is reddish orange in color, because it is the start of the fire that deposits soot, because it is a product of incomplete combustion. So incomplete in the sense that this is not totally caused by fire, or this is not totally consumed by the fire. So that's why the color is reddish orange in color. It deposits soot because it is a product of incomplete combustion. It has lower temperature. That is luminous flame. Another is the non-luminous flame. So what is this non-luminous flame? So non-luminous flame is bluish in color. It does not deposit soot because it is a product of complete combustion. It has a higher temperature than luminous flame. So the non-luminous flame, because the fire is in progress, the fire gets hotter. That is why from reddish orange in color to bluish in color, because the fire is very hot. So the non-luminous flame, it bluish in color, it does not deposit soot because it is a product of complete combustion. So complete in the sense that this is very hot, because the fire is actually in progress and it is very hot. Okay? Just like also if you are going to observe person is going to in the shop using acetylene. Actually, that is called oxyacetylene. Why do you call that to oxyacetylene? It's because there are two hoses. One hose for the acetylene and the other hose for the oxygen. If they are going to start ignite that acetylene, that is luminous. When the operator is going to adjust the oxygen, it becomes non-luminous. Okay? So, non-luminous flame, it blows in color, it does not deposit soot because it is a product of complete combustion and it has a higher temperature than luminous flame. So that is why when acetylene is used, and actually the use in welding metal, because that is, we call that kind of welding is oxyacetylene welding. Why do you call that oxyacetylene? It's because this is a combination of oxygen and acetylene. It is not only acetylene, but a combination of the oxygen. That is why there are two hoses. One hose for the acetylene and the other hose for the oxygen. When the oxygen and acetylene is mixed, the flame from luminous flame to non-luminous flame. But when you are going to start igniting the acetylene, the flame is luminous. When the oxygen is mixed with the acetylene, it becomes non-luminous because it has a higher temperature than luminous flame. Then according to burning fuel and air mixture. Okay, according to the burning fuel and air mixture. Okay. One is premix flame and the other is diffusion flame. Okay, so this is according to fuel, burning fuel and air mixture. So one of these is premix flame. So the example for premix flame, example of a Bunsen burner. Okay? So the Bunsen burner, premix flame. So for the LPG. So premix flame, example is Bunsen burner. another is diffusion flame. So what is this diffusion flame? So the example of the diffusion flame of the oxyacetylene torch. So oxyacetylene torch. So this oxyacetylene torch, the tip of that oxyacetylene, which is used in welding metal, is known as the torch. You are going to ignite that one using lighter or safety match. When you are going to ignite that with the safety match or lighter, you did not yet open the what we call this, the oxygen. It's still the acetylene. Then the flame is what we call this luminous. When oxygen is open and mixed with the acetylene, it becomes non-luminous. And this kind of flame is diffusion. Diffusion flame. The flame example of that is the flame of the oxyacetylene torch. So oxygen and acetylene, which is mixed, and the flame is this kind of flame is called diffusion flame. The combination of oxygen and acetylene. It is different from premixed flame for a Bunsen burner using LPG. But in this case, diffusion flame, this is a combination of the two. This is combined oxygen and acetylene. So this is oxyacetylene. So the oxyacetylene torch is used in welding metal. Because the term is acetylene, but the common term is acetylene. But the right term for that is oxyacetylene. If you want that this metal is going to be combined using acetylene, this is called oxyacetylene welding. The welding is known as oxyacetylene. Why oxyacetylene? Because does not use electrical outlets, does not use electrical circuit. It uses only the oxygen and acetylene. And that flame is called diffusion flame. So example of flame of the oxyacetylene torch. So diffuse, disperse by the spread. Then, based on smoothness. Okay, so another types of flame based on smoothness. This can be classified into laminar flame and turbulent flame. Why is this called laminar and why is this called turbulent? What is the difference between laminar flame and turbulent flame? So a laminar flame, this is also known as smooth flame. The turbulent flame, this is known as rough flame. So a laminar flame, a flame is laminar when a particle follows a smooth path through a gaseous flame. So meaning to say that the flame is smooth or the flame is steady. So when do we consider that the flame is laminar? A flame is laminar when a particle follows a smooth path through a gaseous flame. So it means that the flame is steady. So that is called laminar flame based on smoothness. So the flame is laminar when a particle that follows smooth path through a gaseous flame. How about the turbulent flame? Why do we call this a turbulent flame? So the turbulent flame, which is also known as rough flame. So why rough? So this turbulent flame does having unsteady, irregular swirls and eddies. So meaning to say that the flame is not steady. This is opposite to laminar flame because the flame is unsteady. Irregular swirls and eddies, especially if there are, if in the atmosphere there are enough oxygen or air, which is in contact with the flame. That is why the flame is considered as rough flame. So rough in the sense that the flame is not steady. Irregular trails, and it is, so we call it turbulent flame, especially when it is when strong wind is in contact with the flame. So turbulent flame. It is different from a laminar flame, which is in which the flame is steady, or the flame is following a smooth path that through a gaseous flame. And the turbulent flame is a rough flame, those having unsteady regular trails, and it is. So when rough flame is what we call is in progress, and the what we call is the fire, or what we call is the firefighters will encounter difficulty on this. Okay, so turbulent flame. Next is the nature of fire. Okay, so next to that types of flame, the nature of fire. So the nature of fire, even the most flammable materials capable of being easily ignited do not actually burn. Okay, so the most flammable materials capable of easily ignited do not actually burn. The vapor given off by a material is the part that burns. So the vapors given off by the material is that part that burns. When a piece of wood is ignited, the fire is not from the burning wood, rather from the vapors that are given off by the wood. So the heat causes the substance in the wood to vaporize, and the heated vapor mix quickly with oxygen in the air, and fire results. So this is known as pyrolysis. So when this happens, the fire is known as, or this vapor which is mixed with oxygen in the air, and the fire results, this is known as pyrolysis. And pyrolysis, it refers to the chemical process whereby fire consumes the most solid part of the fuel. So the pyrolysis, which is the chemical process whereby the fire consumes, so the fire that consumes the most solid part of the fuel. It is the thermal decomposition of the solid fuel through the action of heat. That is pyrolysis. So refers to the chemical process whereby fire consumes the most solid part of the fuel. So that consumes the most solid part. Even though that fuel is solid, hard, but that consumes the most solid part of the fuel. Then the process of pyrolysis involves the following. 1. The fuel is heated until its temperature reaches its fire point. So the fuel which is heated until its temperature reaches its fire point. So the fuel which is now heated until that reaches to a fire point. Talking about fire point, is about to start the fire. Then the composition takes place. Moisture in the fuel is converted to vapor. So the decomposition of the takes place. Moisture in the fuel is converted to vapor. When this fire is decomposed, when the fuel is decomposed, this is converted to vapor. So when moisture in the fuel is converted to vapor, then decomposition produces combustible vapors that rise to the surface of the fuel. So when it is decomposed, it produces combustible vapors that rise to the surface of the fuel. And these combustible vapors that rise to the surface of the fuel, these combustible vapors are technically termed free radicals. So these combustible vapors, which is called free radicals. And the free radicals undergo combustion if proper amount of oxygen is present. So if more oxygen is present, the free radicals will undergo combustion, can be consumed by fire if proper amount of oxygen is present. Then the most common types of free radicals are the combustible vapors are hydrogen gas, carbon monoxide, carbon dioxide, and nitrogen. So these are the most common types of free radicals. When enough oxygen is present, it will cause fire. Okay. Next is the heat. So what is heat? So heat is a form of energy measured in degree of temperature. It is the product of combustion that spreads the fire. It causes burns and other injuries such as dehydration, heat exhaustion, and respiratory tract injuries. Heat, oxygen depletion, and carbon monoxide formation are the primary hazards in fires. So energy transferred from one body to another when the temperature of the bodies differ. So the heat is the most common form of energy found on Earth. So the temperature is an indicator of heat and is measured the warmth or coldness of an object based on some standard. So in most cases at present, the standard used is based on the freezing point, 32 degrees Fahrenheit and 0 degrees centigrade, and boiling point, 212 degrees Fahrenheit and 100 degrees centigrade of water. And the temperature is measured using degrees Celsius. So the temperature is measured using degrees Celsius in standard instrument and degrees Fahrenheit in the customary system. So that's the heat. So the form of energy that measures the degree of temperature. Okay, the degree of temperature of the heat. So the hotness of the product. Okay, so this is a product of combustion that spreads the fire. So this heat, which is the product of combustion that used to spread the fire, to increase the fire, that causes burns and injuries such as dehydration, exhaustion, and respiratory tract injuries. Then the last is the smoke, which is the visible product of incomplete combustion, usually a mixture of oxygen, nitrogen, carbon dioxide, carbon monoxide, finely divided particles of salt and carbon, and miscellaneous assortment of product released from burning material. So this is the smoke, the visible product of incomplete combustion. So when there is a smoke, it means that the fire is not it's not a complete combustion. This is a result of incomplete combustion because of the smoke. So this is a visible product. So visible in the sense that this can be observed where the fire is in progress, especially if the fire is started or the materials involved in the fire are humid or wet. Okay? So it is the visible product of incomplete combustion, usually a mixture of oxygen, a combination of oxygen, nitrogen, carbon dioxide, carbon monoxide, finely divided particles of soot and carbon, and miscellaneous assortment of products released from the burning material. Okay? So that ends our topic for this morning. So this morning, we discuss the types of energy. There are types of energy such as chemical energy, electrical energy, nuclear energy, then mechanical energy. Then we discuss also about the factors involving electrical heating, about the types of flames. Okay, the categories of products of combustion, the fire gases, flame, heat, and the smoke. Okay, so that ends the topic for this morning.